Welcome to the Mullet YouTube channel. If you enjoy this content, please like or share. And if you'd like to support the Mullet by becoming a Mulleteer, visit us on Patreon. We appreciate your support. Well, good afternoon. Timothy Clancy here for another segment of Structured Systems Thinking. Real simple application. Today we're going to look at a wave pattern and we're going to understand what we're seeing. We're going to articulate a problem that we want to solve with structured systems thinking, looking at this wave pattern, use a little bit of analysis that we get from our tools and our methods, and then see if that informs a policy decision. So let's get started. So this wave pattern was released by JP Morgan. The vertical axis is the number of net infections, and the horizontal axis is the time. Wave 1 increases in infection. We put in place social distancing and restrictive movement orders. Infections decrease. And we do that because this top line here is hospital capacity. So as we reach this point where we're failing to flatten the curve, that's when we, or hopefully before, put in place some of these restrictive movements. But as infections decrease, there's a decision here to relax restrictive movement orders. And what JP Morgan's pointing out is that's going to present another wave of opportunity potentially where infections will increase again to a lower level because we're increasing hospital capacity. So it's going to be at a lower level. We'll be able to once again turn on restrictive movement and quarantines to help flatten the curve. And we'll be in this oscillating pattern of wave 1, 2, 3, potentially more. What they're saying, until the vaccine is developed, we may have a series of on again, off again restrictive movement orders. What's the policy question? Let's say we wanted to reduce the impact by reducing the number of on again, off again quarantines. How would structured systems thinking help us? But we know that this oscillating pattern is attenuating, and we know that because it's larger at the front, it's got a higher amplitude from trough to peak than it does at the end. It's a smaller. That means it's attenuating. It's getting smaller over time. And structured systems thinking tells us that an attenuating oscillating pattern is caused by two negative feedback loops. One negative feedback loop is driving to an equilibrium. The other is creating an oscillation. And as those two feedback loops interact, what you have is this attenuating pattern. The first negative feedback loop, the pandemic, it's seeking an equilibrium of infecting the population. That makes sense. It's the one that's driving this upward behavior that is resulting in infections. And left alone, it would reach an equilibrium. The second negative feedback loop is probably the policies and decisions to put in place the restrictive movement orders and the social quarantines. It's the one that's creating this oscillation. And the decisions of when to implement it or lift it have to do with these number of oscillations. And if you want to reduce this tug and play between these two feedback loops, it's the time delay that's driving each feedback loop that's going to determine its relative strength. And the stronger that loop is relative to the other, the more of that behavior will dominate. So if the policies to implement quarantine are stronger or relatively faster, it's going to create oscillation patterns. And what we think of this from a policy standpoint, we can think of it as the time delay in which we wait to lift the restrictive movement orders, not when we put them in place, but when we lift it. If we put it in place here, and we have a short time delay means we're strengthening that negative feedback loop, we're making it faster, then we're going to quickly relax the social distancing too early. We're going to get ahead of ourselves and probably create an error because our hospital capacity isn't caught up yet. The virus is still out there. So the faster we release those, the more likely we are to have a second wave. And again, in the second wave, we'll put in place restrictive movement, go back into quarantine, we'll see the infections drop. And again, if we're too quick, you can think of this like how you're turning a shower handle to get this right temperature of warm water. If you're constantly moving the handle all the way to the hot, it takes time for the pipes to catch up. By the time it catches up, it's way too hot. And then we turn it all the way to the right. If we actually were slower in how we turn the shower handle and waited, we'd probably be able to adjust it into the right temperature. Likewise, the faster we make these decisions to lift social quarantine, the more waves you want to have. So if the problem we are facing is how to reduce the number of sequential waves that we're going to face, well, the answer is pretty simple. Take our time in deciding when to lift social quarantine and restrictive movement orders. Obviously, that has an economic impact. Maybe there's a trade-off, and we have to decide for economic reasons that we're going to accept lots of sequential on-off, and in which case we'll make fast decisions. But we need to be aware that when we make fast decisions, we're making this oscillation pattern worse. And if we want to reduce the impact of the oscillation pattern, we need to take our time in making decisions on when to lift it. Hope this has made sense. Have a great day. Thanks for watching the video. Hope you enjoyed it. If you'd like to follow the InfoMullet, visit us on Facebook or Twitter. And if you'd like notifications when we post new video content, click on the red subscribe button below the video. If you've ever wanted to become a mulleteer and support the InfoMullet, visit us on Patreon. We appreciate the support.